Hi, my name is Kian Morrison, and from my ELTR 2402 Capstone project, I have built a small-scale radio telescope. This project is able to scan across the sky and create a low-resolution image of signals within the Ku band of 12 GHz to 18 GHz within the night sky. This would consist of TV satellites and of the sun and moon. The telescope uses two NEMA 23 stepper motors to drive the small 19 by 21-inch satellite dish mounted on the top of the enclosure. These two motors are able to tilt and rotate the dish with ease to pan across the sky. For rotating the dish, a Lazy Susan turntable bearing is used for smooth rotation, and with a filament spool bolted between the bearing and the dish mount. The stepper motor uses a 3D printed wheel with a rubber grip to contact and rotate the spool in small increments to turn the dish. For tilting the dish, a system similar to reeling in a fishing line is used. The motor is bolted to the base of the dish mount and will use a 3D printed spool to reel in and out a paracord connected to a piece of metal with a counterweight attached to the back of the satellite dish for leverage. When running, the motor will move the dish up about 70 degrees for each vertical sweep. After powering up the telescope, a serial connection between a Raspberry Pi and an Arduino needs to be established using PuTTY. PuTTY will also save a CSV file for all the recorded data during the program's course. Once this is completed, the telescope is ready to run. Pressing the button next to the display will begin the program's main code. The motor which controls the tilt of the satellite instantly runs a small distance, which picks up any slack in the cord, and then the motor begins to pulse as it moves the dish up in small increments. Between each pulse of the motor, the microcontroller takes a reading of what the satellite is picking up. The bigger the number, the stronger the signal. Each reading can be seen as it is taken on the display. Once the end of the scan is reached, the motor will stop in reverse, bringing the dish back down to its original position. Then the rotation motor will run and slightly turn the dish clockwise, and then the code will repeat. In total, the telescope will have 64 readings per vertical scan, which is done 40 times horizontally across the sky. The CSV file, which is saved to the Pi, can then be transferred onto an external computer for post-processing. Now, the internal components that make the telescope work will be overviewed. To detect the signals picked up by the satellite dish, a basic satellite detector is used, which has been modified to interface with the microcontroller. This component outputs a frequency which increases as the inputted signal from the satellite dish gets stronger. For the microcontroller, an Arduino Nano was chosen. The Arduino receives, measures, and outputs the signal from the detector into a Raspberry Pi. Along with this, it is also connected to the stepper motor drivers to control them. For the Raspberry Pi, a Pi 3 Model A Plus is used. This records all the radio signal data that the Arduino reads from the satellite detector and saves it into a CSV file. For stepper drivers, two TB6600 microstepping drivers are used. These drivers have been configured to 132 microstepping and max current output to ensure the accurate movement of the stepper motors and allow them to have enough torque to move the dish. For power, a 24 volt 14.6 amp mean well power supply is used. This power supply is paired with a custom PCB with two buck converters mounted to the top. These give the required 24 volt, 12 volt, and 5 volt voltages required to power the telescope. Once the scan is done and the CSV file is done being written to, it is then transferred to an external computer and imported into Microsoft Excel to be converted into an image. Using the conditional formatting tool to create a new rule and setting the low values as black and the high values as white, the range of values can be converted from a chart of numbers into a colored image. This turns the recorded values into a low-resolution black and white image, where black is where no radio signal is picked up and white is where there is a strong radio signal. In the center of the picture shown, a white circle shape can be seen. This is a desk light using a fluorescent ring bulb that is acting as an artificial sun, which was in the middle of the satellite dish's path as it was doing a scan. While crude, this shape can be made out, and upgrades in the future will only improve this image quality.